Hi class, here are our notes on piecewise functions. A piecewise function is a function that is defined over a sequence of intervals. We have worked with piecewise functions before. They look like this. So it's like different pieces of different functions, but kind of coming together as one function. So it's several different pieces, which is why it's called piecewise. So we're going to do some things with piecewise functions. So today we're going to evaluate piecewise functions. That's this first section. We're going to graph piecewise functions, and we are also going to write the equation given a graph of a piecewise function, and then we'll also quickly talk about domain and range. So let's start with evaluating. I already color-coded each little piece of these functions. So if you want to pause and do so as well, feel free to do that. There's two functions. There's f of x, which has two pieces. And so the red piece is defined by the equation -1/2 x, but that only happens if x is greater than 4. So part of a piecewise function defines where that part exists. And then the next part is the orange part, which is defined by 2x plus 1. But that part only occurs if x is less than or equal to the number 4. Then we have the g function. So g of x is this function. This function is defined by 3 parts. So the function is defined by the number 5 when or if x is less than the number -1. It is defined by the green part, -3x plus 4. If x is in between the numbers -1 and 3. And finally, we're defined by the blue part, just x, if x is greater than 3. So when we're evaluating, there's a couple things we need to do. We need to decide, are we working with the f function or the g function, and which piece of that function am I plugging into? You're only plugging in to one piece of the function. So let's start with example A, which says f of 4. So since there's an f, it means we're working with this function. And since x is equal to 4, I'm plugging in to the orange part because the orange part occurs if x is either less than or equal to the number 4. Well, if x is 4, then it's equal to 4. So we are plugging into the orange part. So the orange part is 2x plus 1, and I'm plugging in 4 to that. So that's 8 plus 1, which is 9. Okay, so the next problem says f of -2. So for f of -2, we're still working in the f function, but we have to figure out, is this going to be plugged into the red part or the orange part? Well, -2 is less than the number 4. So we are still plugging into the orange part because it falls into that category. So we are, again, plugging into 2x plus 1. So I am plugging in -2 for x. So that's -4 plus 1, which is -3. The next example says f of 10. So again, we are still working in that f function. And this time we're plugging in the number 10, which is larger than the number 4. So I am now going to plug into the red function, this one. So we plug in to -1/2 x. So we're going to do -1/2 times 10, which is -5. Moving on to g of 0. So now we're going to be working in the g function, and 0 falls in between the numbers -1 and 3. So we're going into the green part. All right, so 0's in between the numbers -1 and 3. You will never get an x value that falls into more than one category. It's only going to go with one of the pieces. If it goes with more than one of the pieces, then it's not a function. So it's only going to work for one section, and in this case, it's the green one. So we're plugging in 0. So the equation is negative 3x plus 4. I'm plugging in 0 for x. So that is negative 3 times 0, which is 0, plus 4, which is 4. All right, letter E, g of negative 3. So we're still working in the g function. Negative 3 is less than the number negative 1. So now we're working with the yellow part, which is defined by the number 5. There is nowhere to plug an x into. So I kind of like this section because if we get an x value that's less than negative 1, we have an automatic answer of 5. So this literally just is going to equal 5. There's no x to plug into. It's just like an automatic answer. So now g of 3, we're still working in g. Careful, because there's 2 sections that have the number 3, but only one of them should say or equal to. So the or equals part is the green, which means we're plugging in to the green equation, negative 3x plus 4. And we're plugging in 3 for x. So that's negative 9 plus 4, which is negative 5. Okay, moving on. G of 12. So 12 is greater than the number 3. So we are going to go into the blue function. And I plug in here, so I'm just plugging in for the number x. So the answer is just 12. X is 12. Plug it in, I get 12. Finally, g of negative 1. So again, this, I see negative 1 in 2 spots, but there's only one spot that's or equals, and that's the green. So we're going to plug into the green, which is negative 3x plus 4. And I'm plugging in negative 1. So negative times negative gives me a positive 3 plus 4, and that's 7. So that is how we evaluate a piecewise function given just the equations. We are going to move on to graphing. So there's several different ways to do this, but I actually prefer to make a chart only because sometimes I get confused with this part, like the x is greater than 2 or the x is less than 2. So even with this piecewise function, which should be pretty simple because it's 2 linear equations, I would personally still make a chart. So if I am going to, let's see, if I'm going to graph the first one in red. If I'm going to graph this, I'm going to graph it only when x is greater than the number 2, which is why like you don't want to do y equals mx plus b and do the y-intercept because the y-intercept might not be part of the actual piecewise part. So I'm going to make a chart. To make your charts for the red part, I'm going to do an xy chart. And here's my suggestion. You always start, whether it's inclusive or not, with this number. So we're always going to start with the number 2 for x, even though it's not inclusive, it's going to be an open circle. And then I need to pick x values that are greater than 2. I would choose 3, but that'll give me a fraction because I'm plugging into this. And so since it's 1/2, I'm only going to pick even numbers. So 2, 4, and 6. This is linear, so I don't need a ton of points. And we're just going to plug in. So negative 1/2 of 2 is negative 1. Negative 1/2 of 4 is negative 2. And negative 1/2 of 6 is negative 3. So I mentioned this already, but this is going to be an open circle at 2, negative 1, because this is not including the number 2, but it does start there. So you have to have your open circle on this number, which is why I suggest always to start with that number when you make your chart. So 2, negative 1 is my first point, which is right here. It's going to be an open circle. My other points are 4, negative 2, and 6, negative 3. Some teachers might just say once you get that starting point, you can just go down 1 over 2. Just count the slope, which is totally fine. But the reason I like this is because it helps me drawing my arrow. X is greater than 2, which means I'm drawing the arrow only in this direction towards my other points. It is not less than. So I cannot draw a line that's over here because all of these x values are less than 2. Now I have to do the second part. I'm going to do the second part in green. This part is also linear. I'm going to, again, make an XY chart. To me, it's the easiest way to do these. And I'm going to start with the number 2. This time it'll be a closed circle there because we are inclusive. There is an underline. And I'm going to plug in, let's see, we need to pick numbers less than 2, and they don't have to be even because I'm not dividing by 2, I'm multiplying. So I'm going to go 2, 1, and 0. I pick numbers less than that at less than 2 because of this symbol, which says less than 2. So 2 times 2 is 4, plus 1 is 5. I'm plugging in the number 1 next to the green equation. 1 times 2 is 2, plus 1 is 3, and then 0 plus 1 is 1. So I'm going to have a closed circle on 2, 5, which is right here. Then I have the point 1, 3, and then 0, 1. So you have to be careful because you have to draw the arrow in the direction. So I always start at the point I start with and draw my arrow in the direction of the other points, which again, I think using a chart makes it easy to figure that out. Some students struggle with which way am I supposed to draw the arrow. So it takes practice. All right, let's do another one. This one's going to have a nonlinear part to it. So for example 2, I'm going to go, let's go orange for this part. This is the equation x squared. If x is greater than -2. So I am going to make my xy chart. I have to start with the number -2. And this is a quadratic, so I don't want to just pick 2 or 3 points like with a linear. I am going to want to pick a bunch. So I am picking numbers greater than -2. So -2, -1, 0, 1, and 2. All of these numbers are greater than the number -2. -2 squared is 4. -1 squared, I'm just plugging in here. -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. This is going to be an open circle on the point -2, 4. So -2, 4. Then my points were -1, 1. These are all closed. It was 1, 1, and 2, 4. I am only drawing, watch this, an arrow one way. So I start with my first point and I draw my curve in the direction of the other points. There's only one arrow. And then the second part of this, let's go with blue. Okay, is linear. I'm going to start my chart. You got to start it with the number -2. It is a must. Now, I have to pick numbers less than -2, and keep in mind, since this denominator is 2, I'm going to want to pick even numbers. So I'm going to go -4 and -6. Okay, plugging in, we get -3/2 times -2, which is +3 minus 6 is -3. Whew, okay, -4 times -3/2 is going to be 12/2, which is 6 minus 6, which is 0. And then -6, that's going to be 9 minus 6, which is 3. So this is going to be a closed circle because we are underlined here on -2, -3. And then my other points are -4, 0, and -6, 3. So whenever I draw the arrow, I start at the point that my chart starts with, and I draw the arrow in the direction of the other points I found, which is this way. And that's it. That's a piecewise function. So my suggestion, like I said, is to always make a chart. Now, the very last part of this is writing the equations. So these also should have arrows on them. They're kind of outdated graphs, and the program we used to use didn't allow us to make arrows. So here, these should have arrows. I'm going to add them on both parts. Okay. So be really careful. Let's start with this section. Okay, this is a V, which is an absolute value. Let's count the slope on both sides. So I have my vertex here, which is from the origin left 5 and down 3. So we'll utilize that in our equation. And then the slope on both sides is up to right 1, up to right 1, up to right 1, and also up to left 1. All right. It's going to look like this. Let's write, I'll do a different color. Let's go f of x equals, I'm going to actually write this part right here. So this went a slope of 2. It went left 5, which in the equation is going to be a plus 5. Remember, it goes in the opposite direction when it's inside, and it also went down 3. So that is my absolute value equation. So I'm going to do this big fancy bracket, and I'm going to write the first part to absolute value of x plus 5 minus 3, and that happens if x... So here's the breaking point. I suggest highlighting that. And since the v is to the left of that, it's less than. And again, this is open, so it's not or equals. So the v is to the left of the break, which occurs at x equals -1. So if x is less than -1. The linear part, we're going to want to find the y equals mx plus b. So there is a y-intercept here of -1, and the slope goes down to right 1, down to right 1. So it's y equals -2 over 1 x minus 1. So I'm going to write that in my equation, -2x minus 1. And that's happening at the breaking point, which is x equals 1. And since this is to the left of that, it's greater than. And since it's a filled in circle, it's or equals. And that's the answer. Okay, last but not least, this one is going to have 3 chunks. So f of x equals, there is a breaking point at x equals 0, and there is also a breaking point at x equals 4. All right, these are all linear, so it shouldn't be too bad. This first one, let's see, the slope is +1, up 1, right 1, up 1, right 1, up 1, right 1. The y-intercept is at 7. So the equation, I'm going to write it right here, is y equals 1x plus 7. This middle chunk is constant. It's a horizontal line at 4. So it's y equals 4. And then this one is a little bit hard because it doesn't hit the y-axis. So first let's figure out the slope. Down 1, right 2. Down 1, right 2. So the slope is -1/2 x. Now, if I continue that pattern, up 1, left 2, up 1, left 2, I can see that the y-intercept of this would be 4 if I kept going. So that's what I use. It would be 4. So now I'm going to write this. Let's start with the x plus 7. So that is happening if x is to the left of 0. So since it's to the left, it's x is less than 0. The middle chunk, which was just at the number 4, is if x is in between the numbers 0 and 4. And these are inclusive because these are my filled in circles. So if x is between 0 and 4 inclusive. And finally, we use this equation, -1/2 x plus 4. If x is greater than, to the right of, the number 4. So that's the answer. We can talk about domain and range when I see you next. So don't worry about it for right now, but hopefully all these piecewise examples make sense. We'll recap it when I see you next.